Good morning friends. Today I will discuss you about the viscosity. See, if you put a drop of the water on a plate, you will find that the water spreads out immediately. And the second liquid, if you take the honey, you put a drop of the honey on the plate, it remains as such. Then what we observe that the water is spreading in all the directions while the honey drops remain as such on the plate. Then what actually we say that the water is less viscous as compared to the honey. So what is the viscosity? How we will define it? First we see the definition is defined as internal resistance. Listen, internal resistance to flow in liquids which arise due to the internal friction between the layers of the liquid as they slip past one another while liquid flow. Here two terms, that is the internal resistance and the layers of the liquid. Internal resistance, it is simple, a resistance in the liquid which is against the flow of the liquid. But what do you mean by the layers of the liquid? It means liquid is having layers which are one above the other. Suppose a drop of liquid consists of a large number of the molecular layers. When drop is taken on the plate, now due to the intermolecular force of attraction, the water molecules, they come close to each other and they form layers, that is the molecular layers. See here, a drop when on the plate drops, it is in a stationary layer, first layer which is in contact with the plate, that is a stationary layer, then the second layer, third layer and the fourth layer. Now the second layer, it flows slowly, then the third layer flows having more speed. In the same way, the speed of the layers increases. First layer is stationary, but the second layer moves slightly faster and the third one with more speed. So we say that the gradually speed of the flow is increasing. So there is a gradual increase in the speed of the layers, and this type of the flow is known as the laminar flow. So whenever gradual increase in the speed of the water in the layers, that is known as the laminar flow. So it means that the water is having layers of the, that is known as the molecular layers. Now due to internal molecular force, there is a resistance of one layer to the other, that is the friction force between the two layers. Due to intermolecular force, there is a resistance of one layer to the other layer and the flow is retarded. Listen, retarded means a friction force between the two layers. The flow is retarded in the lower layer and then flow of the upper layer gradually increases. So suppose this is the stationary layer, this is the first layer. Now when this first layer flows upon the stationary layer, there is a frictional force between two layers, but when the third layer comes into, then the speed of the third layer will, on the second layer, it will increase because the friction force will be less. Now suppose distance between the two layers is dx and the change in the velocity between two layers is dv, then velocity gradient is dv upon dx, that is change in the velocity per distance. Now some force is required to maintain the flow. Force is required to maintain the flow. So force is directly proportional to the area and force is directly proportional to the velocity gradient. Then force is directly proportional area and the velocity gradient, or we say that force is equal to the coefficient, that is velocity coefficient, area and the dv upon dx. Now here, listen. If we say that the area and the velocity gradient is a unit, then this velocity coefficient is equal to the force. If area and the velocity gradient is a unit, then force is equal to the velocity coefficient. So this velocity coefficient is the force of friction required to maintain the unit velocity gradient between the two parallel layers of unit distance. So the main point is the friction force between the layers. So velocity coefficient is the force of the friction required to maintain the unit velocity gradient between two parallel layers of unit distance. So this is the viscosity. So simply viscosity is the internal resistance to flow in liquids which arise due to the internal friction between the layers of the liquid as they slip past one another while liquid flows. So here layers of the liquid means molecular layers of the liquid. So the point is that internal resistance, that is the friction force between the molecular layers. So suppose a drop of liquid consists of the large number of the molecular layers. When drop is taken on the plate, so dx is the distance between the two layers and change the velocity is the dv. So force is directly proportional to the area and the force is directly proportional, that is velocity gradient, and A is the area. So we say that the force is equal to a velocity constant, area and the velocity gradient. If area and the velocity gradient is a unit, then we will say that the force is equal to the velocity coefficient. So here velocity coefficient is the force of friction required to maintain the unit velocity gradient between the two parallel layers of unit distance. So this is the viscosity. I think it will be clear to you. If you like my videos, please share and subscribe. Thanks very much.